Now examples of applications of derivative. In that one, find the point on the curve y equals to x cube minus of twice of x square minus of x, where the tangents are parallel to 3x minus of y plus 1 equals to 0. So here let the required point is x1 y1 on the curve x cube minus of y is equals to x cube minus of twice of x square minus of x. So we differentiate this curve with respect to x. So derivative of y dy by dx is equals to derivative of x cubed 3x square minus of 2 into derivative of x square is twice of x minus the derivative of x is 1. So here dy by dx is equals to 3x square minus of 4x minus of 1. So therefore dy by dx at point x1 y1 is equals to 3. We replace here x by x1 and y by y1. It means 3x1 square minus of 4x1 minus of 1. So this is the slope of tangent at x1 y1, but tangent is parallel to the line 3x minus of y plus 1 equals to 0, whose slope is, so here minus of coefficient of x divided by coefficient of y. So here minus of coefficient of x is 3 divided by coefficient of y is minus of 1. So therefore the slope of this line is 3. Now we know if the lines are parallel, so their slope must be same, and if the lines are perpendicular, then their product of the slope is minus of 1. So here tangent and this line 3x minus of y are parallel, so therefore the slope of them must be equal. So therefore slope of tangent is equals to 3. But at point x1 y1 slope is 3x1 square minus of 4x1 minus of 1, and therefore 3x1 square minus of 4x1 minus of 1 is equals to 3. That is 3x1 square minus of 4x1 minus 4 is equals to 0. Now factor for this equation. 3 4s are 12 and product of 3 and 4 means 6 2s are 12. So minus of 6 2. So here 3x1 square minus of 6x1 plus twice of x1 minus of 4 is equals to 0. So we are taking here 3x1 common, it means x1 minus of 2. Here plus 2 common, it means x1 minus of 2 is equals to 0. So therefore x minus of 2 into 3x1 minus of plus 2 is equals to 0. So therefore x1 minus of 2 is equals to 0, or 3x1 plus 2 is equals to 0. It means x1 is equals to 2, or x1 is equals to minus of 2 divided by 3. Now as point x1 y1 lies on curve x cube minus of twice of x square minus of x, so y is equals to this one. So therefore y1 is equals to x1 cube minus of twice of x1 square minus of x1. Now we put the value of x1 is equals to 2. So whenever x1 is equals to 2, y1 is equals to 2 cube minus 2 into 2 square minus of 2. So here 2 cube means 2 to the 4 to the 8 minus of 2 square means 4, 4 to the 8 and here minus of 2. So here y1 is equals to minus of 2. So here one point is x1 y1 is equivalent to 2 minus of 2. Now whenever second value for x1 is equals to minus of 2 divided by 3, so y1 equals to, so here minus of 2 divided by 3 cube of this one minus of 2 divided by minus of 2 divided by 3 square minus of 2 divided by 3. It means here 2 square means minus of 8 divided by 27 minus 2 square means 4 to the 8 divided by 9 and here plus 2 divided by 3. So we take LCM as 27. So this one is minus of 8. Then 9 3 is 27, 3 4 is 3 8 is 24 plus 3 9 is 9 2 is 18. So answer will be y1 equals to minus of 14 divided by 27. Hence second point x1 y1 is equivalent to x1 means minus of 2 divided by 3 minus of 14 divided by 27. Hence the required points are, so here 2 minus of 2 and minus of 2 divided by 3 minus of 14 divided by 27. The second example, find the point on the curve y is equals to root x minus of 3 where tangent is perpendicular to the line 6x plus 3y minus 5 equals to 0. So we consider let p x1 y1 be the required point on the curve y is equals to root x minus of 3. So we differentiate with respect to x. So therefore dy by dx is equals to derivative of root is 1 divided by 2 root x minus of 3 into derivative of x minus of 3 is 1. So therefore dy by dx at point x1 y equals to replace x by x1 y by y1. This one is 1 divided by 2 root x1 minus of 3. So here derivative of dy by dx at x1 y1 is equals to this one. So therefore this is nothing but slope of tangent is equals to 1 slope of tangent at x1 y1 equals to 1 divided by 2 root x1 minus of 3. But given tangent is perpendicular to 6x plus 3y minus of 5 is equals to 0, whose slope is, so slope of this one means minus of coefficient of x divided by coefficient of y. So this is equals to minus of 6 divided by 3, which is equals to minus of 2, and therefore slope of tangent is equals to, here tangent is perpendicular to this one, it means product of their slope is minus of 1. It means slope of tangent equals to minus of reciprocal of slope of line. So therefore slope of tangent equals to minus of 1 divided by minus of 2, which is simply 1 divided by 2. So therefore this value 1 divided by 2 root x1 minus of 3 is equals to 1 divided by 2. To get cancel, it means root x1 minus of 3 is equals to 1. Now squaring on both sides, so x1 minus of 3 is equals to 1, and therefore x1 is equals to 4. Now here as x1 y1 lies on the curve y is equals to root x minus of 3, and therefore y1 equals to root x1 minus of 3. We have to find the value of y1. So here x1 is equals to 4, so y1 equals to root 4 minus of 3. So y1 is equals to root 1, and y equals to root 1 means y equals to plus or minus 1. So therefore x1 y1 is equivalent to 4 plus or minus 1. So therefore the required points are 4 plus 1 and 4 minus of 1. Now next example, find the equation of tangent to the curve x square plus y square minus of twice of x minus of 4y plus 1 equals to 0, which is parallel to x-axis. Now here we have to find equation of tangent to the curve x square plus y square minus twice of x minus 4y plus 1 equals to 0, which is parallel to x-axis. So again here let p x1 y1 be a point on the curve x square plus y square minus twice of x minus 4y plus 1 equals to 0, where the tangent is parallel to x-axis. So therefore x square plus y square minus twice of x minus 4y plus 1 equals to 0. Differentiate with respect to x. So So twice of x, derivative of x square, twice of x plus derivative of y square, twice of y, dy by dx, minus derivative of twice of x is 2, minus 4 dy by dx, derivative of 1 is 0, is equals to 0. So we are taking dy by dx common. So twice of y, dy by dx, minus of 4 dy by dx. Now take dy by dx common. It means dy by dx into twice of y minus of 4 is equals to minus twice of x plus 2. It means dy by dx is equals to minus of twice of x plus 2 divided by twice of y minus of 4. Now divide numerator denominator by 2. So dy by dx is equals to minus of x plus 1 divided by y minus of 2. So therefore dy by dx at point x1 y1 is equals to minus of x1 plus 1 divided by y1 minus of 2. So slope of the tangent at x1 y1 equals to minus of x1 plus 1 divided by y1 minus of 2. But tangent is parallel to x-axis. So therefore slope of tangent equals to 0. Here tangent is parallel to x-axis and the slope of x-axis is always 0. So therefore slope of the tangent equals to 0, and therefore here minus of x1 plus 1 divided by y1 minus of 2 is equals to 0. So that is minus of x1 plus 1 equals to 0. This implies x1 is equals to 1. So this one is the one value of one coordinate, x coordinate. Now we have to find y coordinate. So as point x1 y1 lies on the curve x square plus y square minus twice of x minus 4y plus 1 equals to 0. So therefore x1 square plus y1 square minus twice of x1 minus of 4y1 plus 1 equals to 0. So here x1 means 1. It means 1 square plus y1 square minus 2 into 1 plus 4y1 plus 1 equals to 0. It means y1 square plus 4y1. Here 1 minus of 2 means minus of 1 plus 1 means 0 is equals to 0. So we are taking y1 common. It means y1 plus 4 is equals to 0, and this equation implies y1 equals to 0 or y1 is equals to here minus of 4y1. So minus of 1 square plus y1 square minus twice of 1 into 1 minus of 4y1. So here minus sign. So here minus sign. So here y1 equals to minus 4. Transfer this minus 4 to that side means plus 4. So therefore the points are x1 y1 is equivalent to, so here 1 comma 0 or 1 comma 4. So here next example, if the line y is equals to 4x y square is equals to x cube plus b at point 2, 3. Find a and b. Here given curve is y square is equals to x cube plus b. So differentiate with respect to x. That means derivative of y square is twice of y. Dy by dx is equals to a into derivative of x cube 3x square and derivative of b is constant 0. So here dy by dx is equals to 3a x square divided by twice of y. So therefore dy by dx at point 2, 3 is equals to 3a into 2 square divided by 2 into 3. So this 3 get cancelled, 1 2 get cancelled. So this is equals to twice of a. So therefore slope of tangent at 2, 3 is equals to twice of a. But the line y equals to 4x minus of 5 touches the curve at 2, 3. So therefore slope of tangent at 2, 3 is equals to minus of coefficient of x divided by coefficient of y. So which is equals to, here this equation is y is equals to 4x minus of 5. That means 4x minus of y minus 5 equals to 0. So this one equals to minus of coefficient of x is 4 divided by coefficient of y is minus of 1. So slope is 4. So therefore slope of tangent equals to 4. And therefore this twice of a is equals to 4. It means a is equals to 2. Now as 2, 3 lies on curve y square is equals to x cube plus b. So y square means 3 square is equals to a means 2 into x cube plus b. Here x means 2, again here 2 cube plus b. So 3 square means 9 is equals to 2 into 2 cube. So here 16 plus b, it means b is equals to minus of 7. Hence a is equals to 2, b is equals to minus of 7 are the required solution. Now next example, find the equation of normal to the curve 3x square minus of y square equals to 8, which are parallel to 3x, not 3x, x plus 3y equals to 4, which are parallel to x plus 3y equals to 4. So let x1, y1 be the foot of required normal to the curve 3x square minus of y square is equals to 8. So differentiate with respect to x. So here 3 into twice of x minus derivative of y square twice of y divided by dx is equals to 0. It means minus twice of y divided by dx is equals to minus of 6x. So divided by dx equals to 3x divided by y, and divided by dx at point x1 y1 equals to 3x1 divided by y1. So therefore slope of tangent at x1 y1 equals to 3x1 divided by y1. So this one is slope of tangent, and therefore slope of normal at x1 y1 equals to minus of 1 divided by slope of tangent at x1 y1. So here slope of normal is equals to m equals to minus of 1 divided by 3x1 y1, which is equals to minus of y1 divided by 3x1. But normal is parallel to x plus 3y is equals to 4, whose slope is, so here minus of coefficient of x divided by coefficient of y is equals to minus of coefficient of x is 1 and coefficient y is 3. So therefore slope of normal equals to minus of 1 divided by 3. So this normal and this normal are same. It means minus of y1 divided by 3x1 is equals to minus of 1 divided by 3. So here this 3 get cancelled, minus of 1 get cancelled. Y1 is equals to x1, that is x1 is equals to y1. So as point x1 y1 lies on the curve x plus lies on the curve 3x square minus of y square is equals to 0, and therefore 3x1 square, here 3x square minus of y square is equals to 8, 3x1 square minus of y1 square is equals to 8. Now here x1 equals to y1 means 3x1 square minus of x1 square is equals to 8. It means 4x1 square is equals to 8. 3x1 square minus of x1 square means twice of x1 square equals to 8. So here x1 square is equals to 4, and so x1 is equals to plus or minus 2. So here whenever x1 is equals to 2, y1 is equals to 2, and x1 is equals to minus of 2, y1 is equals to minus of 2, and therefore equation of normal at 2 minus of 2 here y minus of y1 is equals to slope into x minus of x1. So slope of normal is minus of 1 by divided by 3, and the point is 2. So here equation of normal at point 2 2. So here y minus of 2 is equals to slope is minus of 1 divided by 3 x minus of 2. It means 3y minus of 6 is equals to minus of x plus 2. It means x plus 3y minus of 6 minus 2 is equals to 0. So x plus 3y minus of 8 is equals to 0 is one equation of normal. And for second point, so here secondly, equation of normal at minus of 2 minus of 2 is, again here y minus 2 means plus 2 is equals to minus of 1 divided by 3 into x minus of 2 means again plus 2. So here 3y plus 6 is equals to minus of x minus of 2. So that is x plus 3y plus 6 plus 2 is equals to 0. We are transferring this term to left hand side. So here x plus 3y plus 8 is equals to 0 is the another equation of normal. So therefore the equation of normal are x plus 3y minus of 8 is equals to 0 and x plus 3y plus 8 equals to 0.